Transformation of trigonometric functions. Question 6. Sketch y equals to minus 2 sine of half x plus 45 degrees plus 1, and x is between 0 to 360 degrees. Now, I already explained you in question 5 how to sketch a sinusoidal transformed function. Now this one I would like you to sketch. So at present you can stop my video and sketch this. And I'll prefer if you could sketch this on a graph paper and make a rough sketch. So do two different sketches. One I should say graph the function, the other one I should say sketch a function. Correct? Do both of them, because in the test both kinds of questions are asked. Sometimes you need to graph it, sometimes you need to sketch it. Right? Now once you've done it, you can move on and see my suggestion. Here is how I would like to do it. So the first method to graph it. Let me just do it graph. When I write graph, then I mean very precise values, correct? That is what. Then imagine that this is a graph paper on which I am working, and I will not really sketch or graph the function, but I'll give you critical points. Now once again, what are the critical points for a sinusoidal function? Let's try to understand. So let me graph and let me just draw a sinusoidal function for you. So basic sinusoidal function is kind of like this, right? So sketching to explain is no harm done. It's actually a good idea, right? So that saves time. Perfect. So a time period of 0 to 360 means this is 0 and this point is 360 and that is 180. This is 90 and that is 270 for us. So these are critical points for sine theta, which is in degrees, and here we have y. Perfect. Now that actually gives us the default values of sine function. So what we will do is we'll use transformation and then graph the function, correct? So when you want to transform, first let's see the initial points which are on sine theta, right? So initial point on sine theta, let me call this sine theta as function, right? Then these are my theta values and this is my sine theta values, right? It's a function which is shown here. So we'll start with 0. At 0, sine theta is 0, correct? And at 90, we have a value of 1, right? At 180 degrees, we have 0. Now 270 gives us minus 1. And 360 degrees, it comes back to 0. After that, the function repeats. It's a periodic function with a time period of 360 degrees. Perfect. Now let's do transformed function, right? Transformed function we're talking about is this y value, correct? That's our transformed function. So what is really happening here is, so I've purposely taken theta here so that we don't write x and x transformed. So we'll get how theta gets transformed to x position, okay? Now, so what is the transformation taking place? Let's start from inside function. Inside is always for x-axis. That means theta or x-axis, correct? So what is happening here is your x values, that means the theta values, original values, get multiplied by 2 and this is plus 45. So deduct 45. So what you do here is that you write x values here will become, this is the x values on your function, will become 2 times this theta values, right? Because this is how reverse of this. Everything you do here is reverse inside. If it is plus 45, just do minus 45 degrees. Don't think. Okay, so that is your x values. And how about the y values? The y values in this case will get multiplied by minus 2 and then you add 1. For horizontal translation, 1 unit up. Minus 2 means reflection on x-axis, so it makes all y values negative, and then multiply by 2. So we do minus 2 times the values here, right? So let me write those as y initial values and then we'll write plus 1 to them, right? And we can use a calculator to do quick calculations if required. Now the first value is 0, so not much requirement of calculator. So we get 0 times 0 is 2 is 0 minus 45. So the first point will be at minus 45 degrees and the y value will be minus 2 times 0 plus 1. So we get plus 1 here. Okay, 90, right? 90 times 2 is 180. So yes, let's use calculator start. 180 minus 45 will give us 135. So we get 135 here. Correct. And 1 times this is minus 2 plus 1, which is minus 1. Now we get 180 times 2, which is 360, and 360 minus 45 will give us 315. So we get 315 here. 315 and 0 will give us 1. So it fluctuates between, right, 0, 1. Now 270. 270 times 2 is 540, right? And then from there we will take away 45. If we do so, we get 495. So we get 495 here in degrees, and this is minus 1. Minus and minus will make it plus, so it is plus 2 plus 1 is 3. So we get 3 here. Okay, now 0. 360 degrees, 2 times 360 degrees is 720. So we will take away 45 from 720 and we get 675. So 675 degrees here, and when you plug in 0, you get 1 here. So you see the value actually is moving from maximum of 3 to minimum of minus 1. So that is what it is, correct? And once you plot these on your graph, you exactly get your perfect graph. Remember how to select your divisions in the x-axis. Since you have to move by 45 degrees left all the points on the graph, then your minimum division should be 45. So that's kind of a very, very important criteria to look into this problem. Okay. Now the other rough sketch portion is kind of like this. What we do is really we go to the axis first and we say, well, the axis is plus 1, so we'll draw a dotted line here. So I'm just trying to show you the rough sketch now. Correct? This part I think is absolutely clear to you. These are your x and y quadrants, and then you can always plot them and connect them with a smooth graph to get your final function. Correct? Now here this is at 1, so this is at y equals to 1. Correct? And now minus 2 means amplitude is actually 2, but the wave starts from it goes like this rather than rising and falling. It falls and rises, kind of like that. Okay. Now what is really happening is the amplitude is 2, so you'll have a maximum which will be 2 units above it. So that will be at y equals to 3, and the minimum at as shown here, right? And the minimum will be minus 3 on this. So when you do 1 minus 3, you get, sorry, minus 2 on it. So 1, because 2 is amplitude, right? 1 minus 2, you'll get minus 1, which is here. So that is kind of a check on your maximum and minimum value. So we get the same values, correct? Now we need to draw a sine wave, and preferably, because it is saying negative, it's a good idea to go like this rather than going like this, right? So we will just sketch a wave saying, well, that is my wave going like this, and this kind of, okay? So that is my wave. Because it is negative, I'm going like this, correct? Now here, my points will be, time period is half, time period is twice 360, right? Time period you get from k value, which is, let me write on time period t. So time period t is actually 360 degrees divided by k value, which is half. Divided by half means multiplied by 2. So which gives me 720 degrees, correct? So if this point is 0, then that point is 720 degrees. That is what it is. But, 45 degrees is the phase shift. So what is really happening is that the wave really starts 45 degrees before. That means not here, but let's say this is my 45 degrees. So the wave actually starts here and goes like this, correct? And it goes like this, and it goes like this, and it ends like this. And that's the end of my wave. And that is actually the sketch which I will draw. It takes only this much of time to sketch it. And now this, of course, my scale, my y-axis, when I'll draw y-axis, I'll draw from here. This is my y-axis, right? That is my y-axis. Now, to figure out where is x-axis, I already know 1, minus 1, 3. So x is x between these two. 1 and minus 1 gives me my 0, right? So here is my x-axis, which goes like this. So this is x, and that is y for me, and this point is 3 for me, this point is 1, this 0, this is minus 1. Do you get it? Now I will translate this point original, that is 720, and of course these will be minus 45, which I should not be writing, right? So this point is 360 for me, correct? That's 360, and this one, the peak will be in between these two, and that peak in between these two. That means 180 here for me, correct? That's what my original graph in red is. And then I do a phase shift, plugging it, pushing it 45 degrees to the left, getting the orange line this time. So orange line this time is my final graph. And of course, this value here I'll write as minus 45 degrees. This is kind of critical for me, and it will end not at 720, but it will end here. So I'll just draw this point. So each division I'll make of 45 degrees, right? It will be 675 degrees as shown here, which is 720, which I get like this, 720 minus 45. That is where the wave ends, right? Which is 675 degrees. Perfect. So I get my sketch like this. So either way we can draw it. You see, doing this is involving very few calculations and getting a fairly good graph or a sketch for the given question. So that's why I was saying, if the question is to sketch, that is a fairly good option. But well, this is also beautiful. You are given always a graph paper. Plot your points and get an accurate graph. Okay, all the best. I hope you have understood transformations along with sketching graph of sinusoidal functions given any complicated equation. All the best. And then we'll have some test problems for you, and I hope you do well. Thank you.